Hello student, welcome to our third lecture in the course Electrical Machines and Control. In this lecture we are going to address series AC circuits, okay? And inshallah in this lecture we are going to outline some introduction, impedance and phasor diagram. We are going to see the series configuration. We will take some examples. We will inshallah do some examples for voltage divider rule. We are going to see also the frequency response for series AC circuits. We'll take a summary for the series AC circuits, and we'll go through some homework, okay? First of all, the big question here for this lecture is what is a series circuit, okay? Series circuit of any combination of elements, devices, or systems has the basic appearance provided in figure 15.1a, okay? As you can see here, this is the series circuit, okay? From circuit one we know that the element they are connected in series, and inshallah in this lecture we are going to see the AC effect, the AC source effect on RLC circuit. So all the rules for determining series elements for DC network are applicable for AC network also, okay? Now, for the previous lectures, we already talked about resistive element. In chapter 14, we found for a purely resistive element, as shown in figure 15.2, okay, that VR and IR are in phase, and the magnitude of the peak values was determined by Ohm's law. خلاص يا شباب. If we now write both the voltage and the current in the phasor form, we find that the phase angle associated with the voltage current is 0 degree. That is, so this is the voltage that we already have seen in chapter 14, which is the lecture number 2. So VR, voltage over the resistor, which is equal to Vm, which is the maximum, sine omega t. So the VR here has a voltage value, maximum value, and an angle, okay? Same as for the current of the resistor, which is I maximum sine omega t. We know that the current is also has a maximum and an angle, okay, an angle of 0. So now, if we apply if we apply Ohm's law here, we find that IR is equal V of VR over R, which is V with angle 0 over R with angle 0. So we have a value here and we have an angle, okay? So for the further, for the future, therefore, whenever we encounter a resistor in the AC domain, we will assign an angle of 0 degrees to form a complex number, okay? Notation. The standard format will be ZR, okay? ZR is equal R with angle 0. So before in DC circuits, I am going to just give you a conclusion here, okay? Before in DC circuits, we know that the value of the resistor is just only a number, okay? Now in AC circuits, we have a number and an angle, which is 0 for the resistance, as we know. And this is called impedance R, ZR, okay? So it is called impedance of the resistive element and measured in ohm. That we already know, inshallah. We are going to explain more about it, okay? Now, let us take an example, okay? Example 15.1, using complex algebra, find the current IR for the circuit, okay? We said complex here. Complex means we have an angle, okay? We are dealing with angles, okay? For this figure, okay, we have a source here, and we have current, and we have the resistor. the voltage source is, this is the voltage source, is equal to 100 sine omega t, and we have a resistor. So if we change the value because this one is V maximum, okay, we need it to be V RMS. This is the V RMS, okay, and we already know how to calculate it, okay. So divide by R root 2 and you will find the angle is the voltage value is the voltage magnitude is 70.71 and the angle is 0. So if we apply Ohm's law here, so the voltage is 70 with 0.71 with angle 0 divided by 5 ohm, which is resistor with angle 0. So the angle is 14.14 ampere with angle 0, okay. And IR is, because this one is the RMS value, we need it if we need to consider the expression of IR, we should multiply it by root 2, okay, as you can see here, and the value I maximum, which is equal to 20 sine omega t, 20 sine omega t. So this is the answer, okay. And we know that the current of the resistor is in phase with the voltage, is in phase with the voltage. So the angle is 0. That's why the angle is 0, okay. Now example number 2, which is 15.2, using complex algebra again, find the voltage VR. Now we need to find a VR, okay, for the circuit. This is the circuit. We have now the resistor and we have the current. Now we need to find the voltage. So IR is equal to 4 sine omega t plus 30. So as we know that the current and the voltage are in phase, so they should start from the same phase shift. So the voltage must be starting with 30 degree. As you can see here, they start from 30 degree. That's why yes, that's why they are in phase. So the phasor form IR is 4 divided by root 2, which is equal to this value, and the angle is 30. The angle is 30. Shabab, please try to see how to convert from polar to rectangular. This is the current value here, which is in polar form. Try to see how it is divided together or multiplied together by angles in the calculator, okay. Try to do it in the calculator. So voltage is equal to I R Z R, okay. So I with angle, R with 0 angle. So I, this is the same here as we found here, and because it is 2 with angle 0, so the value is 5.656 with angle 30. See, it is the same angle of the current, because they are because it is a resistor, so they should be in phase. They should be in phase, okay. Now we multiply by root 2 to find the maximum, okay. So this is the expression of the voltage, which is 8 sine omega t plus 30. This is the expression of the voltage. خلاص شباب. Now for the resistive element, it is often helpful in the analysis of networks to have a phasor diagram. That's why we have here a phasor diagram, which shows at a glance the magnitudes and the phasor relations among the various quantities within the network. So as you can see here, this is, for example, the example number 1, This is the 70.71. So this is the voltage of the resistor, and this is the current of the resistor. خلاص they are in phase with angle what يا شباب with angle 0 with angle 0. Now we have here for the second example we have the angle to be 30. The angle is 30, right? So that's why the voltage here and the current, they are shifted by 30 degree, and they are the same, they are in phase. That's why they are in phase, just only the difference is the magnitude. Okay, now let's go to the inductive element. Okay, we learn from chapter 14 that for the pure inductive in figure 15.8, okay, the voltage leads the current by 90 degree, or the current lags the voltage by 90 degree, as we already explained. And the reactance of the coil, which is XL, is determined by omega L. We have, this is the voltage expression, voltage of the inductor, which is V max sine omega t, which is V equal to V with angle, okay? Now, if we apply Ohm's law here, we know that I is equal to VL over XL. VL is with angle and XL with an angle also. So the angle of the current, which is the voltage angle minus the XL angle. Okay. Now, since voltage of the inductor leads the current by 90 degree, IL must have an angle of minus 90, because the current lags the voltage by 90 associated with it. So to satisfy this, theta L must equal plus 90. Substituting L 90, we obtain that. Don't worry, Shabab, this is we'll explain more here. Okay. So IL is equal to voltage with angle 0, XL with angle is 90, is equal to 0 minus 90, which is minus 90. This is just to show you that how we find the minus 90. Okay, how we find the minus 90. So the expression is this one. Okay, this is the expression of the current for the inductor. Root 2 to find the maximum, right, Shabab? So V over XL, okay, sine omega t minus 90. We know that the XL here, so we have Z, because this is impedance with angle, so XL with angle 90. Okay. Inshallah, we will see the examples, and inshallah you will find it easy. This is just only derivation of the formula. Okay. Now, using complex algebra, find the current of the inductor for this circuit in figure 15.9. So this is the circuit. We have voltage source. We have XL, which is equal to 3 ohm. Okay, so we need to find the current. Now, VL, we know that VL is 24 sine omega t. As an angle, we have, because we don't have here plus something like this one, plus 30, that's why the angle is 0. Okay, now to find I is VL over ZL. VL is 16.968 voltage volt طبعا. We didn't write here the units. Okay, so 16.968 with angle 0, and the XL is 3 with angle 90. That's why we have the value of the current is 5.656 with angle minus 90, with angle minus 90. Okay, because this angle is going to be up, so it will be in minus. خلاص يا شباب, clear? try to do it in the calculator, and you will find that it is true, we have a minus degree. Okay, now multiply by root 2, as we know, because we need to do it, we need to put it as an expression. So to find the I maximum, which is 8 sine omega t minus 90, this is the angle minus 90. خلاص يا شباب. So as you can see here, we have a shift, and this shift is 90 degree. Okay, we have a shift which is 90 degree. Now, another example, we will find the voltage now as of the resistor, but this one is for inductive element. So find the voltage VL for this circuit. We have the current, and this the current here. We have a shift angle here, okay? And we have an XL which is 4 ohm. So we will find the phasor form, which is the polar form. Okay, this is the value. Okay, because we are dividing here the value 5 divided by root 2. This is the value. Okay, and with angle 90, because he says that the current is shifted by 30 degree. That's why we put it 30 degree here, shabab. And VL is equal to I multiply by Z. I multiply by Z. Okay, shabab. ZL. So I, we have this is the I, okay, and XL with angle 90. This is the XL with angle 90. Why it is positive, shabab? It is positive. The XL is always positive. The XC is always negative. Okay. This is very important, shabab. The as an XL, forget about the current and voltage now. The XL must, the angle of the XL must be positive 90. XC must have an angle with minus 90. This is a must. Okay, shabab. خلاص. Forget about the current and the voltage, lagging, leading. No. If we write the impedance diagram, inshallah we are going to see it. If we draw the impedance diagram, we will find that the XL is always 90 degree plus, and the XC is always minus 90 degree. Okay, this is just only the impedance diagram, okay, so that's why it is here in positive. Okay, so the voltage of the inductor is 14.14 with angle 120. Okay, with angle 120, because we are multiplying here, shabab. That's why we have, if we multiply two angles, we will just add them. Okay, multiply means adding. Now, if we need to find the voltage expression, so multiply by root 2, and this is how we find the voltage expression. Okay. Now, in comparison between the two examples for the inductive, we found that for the example number 1, for the inductive, we know that the voltage is with 0 angle, and the current has an angle of 90 degree. Okay, because we don't have a shift here, and with the magnitude 5.656. Okay, now for the second example, please see the second example to check. Okay, so we have a shift for the current, which is plus 30. Okay, this is the plus 30, and we know that the voltage and the angle between them, they should be 90 degree shift. That's why the voltage now is here. Try to practice, shabab. Try to practice more how to find how to draw the phasor diagram, please practice more and more. You will find it in the midterm. Okay, you will find it in the midterm. That's why I brought you the two phasor diagram for example number 1 and example number 2. okay خلاص يا شباب. Now, for the capacitive element, we have we know that by applying the Ohm's law, we find that V over XC, okay, and if we divide angles, we find that they are in minus. Okay. Inshallah, we are going to take some example. You will see it. Okay, XC is equal to 1 over omega c. This is we already know. Okay. Now, for the IC here, we found that voltage over XC, which is equal 0 minus this is minus from the formula, right, shabab? Because if we divide two, let's say I divide 1 with angle 30 divided by 1 with angle let's say 40. Okay, so the value will be 30 minus 40. خلاص يا شباب. If we divide angles, they should be subtracted. If we multiply angles, they should be added. Okay. Now, this is from the formula. Okay, because we are dividing two angles, that's why we have minus. For the minus 90 here, we know that XC is always, as I said, with angle 90. Okay, this is the one. Okay, this is the one. خلاص يا شباب. Now, if we take this is minus 0 minus 90, which is with angle 90. Okay, plus. This is the expression, as we already know. Okay, so ZC is XC with angle minus 90, with angle minus 90. خلاص يا شباب. Inshallah, with examples, you will find it easy. Okay. Now, this is the same as the previous examples. We are going now to calculate the current. Okay. So this is circuit. We have XC and we have VC. So VC, we need to find the polar form, which is 10 when we find 15 divided by root 2. Allahu Akbar. So we'll find this value with angle 0, because we don't have here an angle. Okay, we don't have here angle. خلاص يا شباب. That's why we have 0. Now, IC is equal VC over ZC, which is VC with angle 0. This is the one. And XC with minus 90. This is, we already know. This should be there. Okay. So XC is 2 ohm, which is this one. خلاص يا شباب. With minus 90. So the angle is 5.3. The value is 5.3 with angle 90 multiplied by root 2 to find the expression of the current. Okay, to find the expression of the current. Okay, this and please see the example here for the waveform, and you will find that there is a shift angle 90 degree. خلاص يا شباب. Please do some practice. You will find it easy if you do the practice. Okay. Now, we have current, we have XC. Now we need to see the voltage. Okay, this is a same procedure for all the examples, same procedures. خلاص. Now, voltage is by Ohm's law, it's I ZC. I, we already know it is minus 60. That's why it is here. Okay, multiply XC with minus 90. XC is 0.5 with minus 90, and you will find the voltage is this one, multiply by root 2 to find the expression. So root 2, it will be 3 sine omega t minus 50 minus 150 minus 150 degree. خلاص. Now, in comparison again with the two examples, we will see that for example number 1, we have the voltage here with angle 0. We have the magnitude is 10.605, and we have current here. Okay, current is leading. Current here is leading with 90-degree difference, شباب, between the voltage and the current. Okay, 90-degree difference. But in this example, example number 2, we have minus 60 degree. Okay. So this is the minus 60 degree with the value, with the magnitude is 4.242, and the with difference of 90 degree again, we have the value of the VC, which is 2 point. So the current, as you can see for the capacitor here, we have current here magnitude bigger than the voltage magnitude, which is okay. So just only focus on the angles, how to write or how to draw the phasor diagram, and mention the magnitude. Sometimes the current is more, sometimes the voltage is more. So this is you should know it خلاص يا شباب by the calculation. Okay. And the angles you should know it from previous lectures. Try to practice more and more. Okay. Now the impedance diagram, as I told you, the impedance diagram for the XL, we have a plus 90. That's why this is the impedance diagram, plus 90. And for the XC is minus 90 minus 90 خلاص يا شباب. And for the resistor is 0 angle. This is, you should know. Okay شباب, read this one. Okay, so for any configuration, series, parallel, and so on, the angle associated with the total impedance is the angle by which the applied voltage leads the source current. Okay, for inductive network, theta t will be positive, whereas for the capacitive network, theta t will be negative, because this is the theta of the capacitive network. Okay, you will find it easy with these examples, shabab. Now for the series configuration, now the overall properties of the series circuits, we know that Z1 is plus Z2 plus Z3. This is the Z total. Okay shabab, this is the Z total, because the current is the same. So Z total is equal to Z1 plus Z2 plus Z3 plus etc. شباب, ها. Okay شباب, this is as circuit 1. خلاص يا شباب. Now this example said that, example 15.9, draw the impedance diagram for the circuit in figure 15.24, which is, this is the one. Okay, find the total impedance. So in this circuit we have he said that we need to find the total impedance and to draw the phasor diagram, the impedance diagram. So R is 4 ohm and XL is 8 ohm. Okay, now we know that Z total is Z1 plus Z2, which is R with angle 0 plus XL with angle plus 90. So R plus JXL, because we have J, because it is plus 90. Okay, plus 90. J is imaginary. Okay shabab, imaginary. That's why we have the Z total here is 4, this is for the resistor, plus J8. J8 means the angle is 90. Okay, so this is the rectangular form. Let me write it here. rectangular form. Rectangular form means I have a value here, r plus jxl. This is the rectangular form. The angle is like j, okay? Or we have plus r plus or minus jxc. خلاص يا شباب. This is the rectangular form. The polar form, okay, is with angle, magnitude with angle. So if we need to change this value from rectangular form to polar form, we will do inshallah some conversion by the calculator. Try to find some videos they are the same, okay? So 4 z total is equal to 4 plus j8, which is equal to 8.94 with angle 63.43. This is just only conversion, okay? Conversion between rectangular form to polar form. They are equal يا شباب. They are equal. The same value. This is the same value. This is the same value. Just only conversion between the rectangular form to polar form. Inshallah, you will see with the videos how to do the conversion. Okay. Now, how to draw the impedance diagram. This is the resistor. Okay, we know that the angle is 0. صح يا شباب. And this is the this is the XL, which is with angle 90. So it is 8 with angle 90. And this is the Z total. Okay, it is only the this is the total Z. Okay, this is the total Z, which is 8.94 with angle 63.43. خلاص يا شباب. Is it clear? Now we'll go to the other. We will see some rules for the series configuration. We'll find that we know that Z total for the series circuit is Z1 plus Z2, and this is for the Ohm's law. And we will find that by finding the voltage across each element. So ZL is equal to the voltage of the ZL. Z1 is V1 I, because the current is the same for Z1, and V2 is equal to I Z2. Okay, this is from the circuit one. Okay, this is for the Kirchhoff voltage law. We know that E is V1 plus V2. Now, for finding the current is for finding the power. Okay, shabab, power. Again, from circuit 1, power is IV. Okay, shabab, صح. IV or V is the same as E. Okay, shabab, the same induced voltage. Okay, so don't confuse yourself. So V or E is the same. So the power is equal voltage by the current. But this one is in DC. Now in AC we have in AC power is equal to I E cosine theta. خلاص يا شباب. We have an angle again for the voltage, for the power. خلاص يا شباب. Now this is how I told you. If the value in many circuits to be considered, 3 plus J4 is the angle with the magnitude 5 with the angle 53. So this is the conversion between the two elements. Now that a general approach has been introduced, the simplest of series configuration will be investigated to in detail with the further emphasize the similarities in the analysis of DC circuit. Okay, so this conversion of the two forms here are used quite frequently to ensure that the approach is clear as possible and no loss of mathematical complexity is found. Of course, the problems at the end of the chapter will provide plenty of experience with the random values. Okay, and this is Shabab. This is the what we call it. Sorry, power factor. Okay, this is the power factor. I'm not sure you know the power factor, but the power factor, when we say the power factor is equal to 1, and it is called unity power factor, so we don't have losses in the system. We don't have losses in the system. Once we have the power is 0, so the power factor, we know that from 0 to 1, from 0 to 1. Once we have power factor is 0, now we have the losses is maximum. The losses of the system is maximum. How to calculate it? The power factor, we know that it is cosine theta, which is R. Again, also it's the same as the R divided by Z total divided by Z total. Of course with angles يا شباب, with angles. خلاص يا شباب. This is how to change from rectangular form to polar form, from this rectangular form to polar form. I already sent you the video. Please see it again, and the how to change it in the calculator. Okay, sorry. Now let us see this example. This is a very good example for the RLC circuit. RLC. Okay, this is very good example, and it is, I know it is long, but this you will, inshallah, you will find it in the midterm, the same example. Try to practice this example carefully. Okay, now we have a resistor value which is 3 ohm. We have XL here which is 7 ohm. We have XC is 3 ohm. Okay, this is the voltage source, which is 70.7 sine omega t, and we know that this is the voltage maximum, right shabab? So now he said we need to find the value of the expression of the current and the voltages, VR, VL, VC, and the current. خلاص. So in order to do that, we know that the current, the voltage is equal to I Z total, because this is the voltage source. So Z total, we need to find the Z total first. Okay, so Z total is equal to Z1 plus Z2 plus Z3, because they are in series, and the angle of the resistor is 0, the angle of the XL is plus 90, and the angle of XC is minus 90. So 3 plus J7 minus J3, because they are in a rectangular form. So the value of Z total is 3 with plus J4, with plus J4. So 3, forget about unit here. Okay, shabab, 3 plus J4. It is the same as 5 with angle 53 point. Why we find here the magnitude? To draw it in here, shabab, huh? So in case I need it to be drawn, we need to find the value. Okay, as a magnitude. This is magnitude and angle, magnitude and angle. We cannot draw this one in the impedance diagram. خلاص يا شباب. Try to do the conversion. Okay, the impedance diagram shown. Okay, this is the 3 ohm, and this is the 7 ohm for the inductor, which is in plus 90, and this is minus 90 for the capacitor, which is 3 ohm. خلاص. So the difference is 4 ohm. Now this is the total, Z total, 5 ohm with angle 53 13. Okay. Now the current is simply is voltage divided by Z total. The voltage is with the zero angle, and the Z total is we already know now, so it is equal to 10 with angle minus 53.13. Okay, خلاص يا شباب. This to find just only to the Z total and I. Okay, the current. Now I already place the values here يا شباب. As you can see here, these are the values that we already calculated. Now, in order to find voltage of the resistor for the inductor and for the capacitor, we need to do Ohm's law here. So voltage of the resistor is I multiplied by ZR. I we already found it, and the ZR is 3 with angle 0, right شباب? So this is the final answer for the voltage of the resistor. For the voltage of the inductor, we know that the XL is plus 90. So multiply them together, so we'll find this angle, this magnitude with angle. VC is again minus 90. So this is the angle and the magnitude of the voltage of the capacitor. خلاص يا شباب. I think it is easy. Try to practice again. Now, to see the expression, to find the expression, just only write it again. Okay, write it again. This is the current. If we need to do the expression, we just ultimately multiply by √2. This is the expression of the current, 14.14 sine omega t minus 53.13. This is the expression of the voltage. This is the final answer يا شباب, huh? This is the final answer. Multiply by √2 to find the voltage maximum of the resistor, and with this is the angle. خلاص يا شباب, the same angle here. Now, for the voltage of the inductor, multiply by √2 to find the maximum voltage, and this is the angle again here. Okay, this is the capacitor voltage, multiply again by √2 to find the maximum voltage, and this is the angle here. خلاص يا شباب, I think it is clear. This is the phasor diagram of the voltage, the phasor diagram, not the impedance diagram. This is the phasor diagram. خلاص. This is the voltage of the resistor. Why it is here يا شباب? Because the voltage of the resistor is minus 53.13. So this is minus 53.13, and the current again, it is the same angle, but the magnitude is different. So this is the current, this is the voltage of the resistor. They are in phase. خلاص يا شباب. This is condition number 1. For the voltage of the inductor, we know that the magnitude is 98. It's almost 100. خلاص. Okay, and the angle is plus 36.87. Okay, this is the one, and the VC is 42.42 with angle minus 43.13. Okay, so this is the difference between the two magnitude, and you will find the voltage source here. Okay, the voltage source here. This is the voltage source. خلاص. I think it is clear شباب. Try to do this example by yourself. Inshallah, you'll find it easy. Now, for the divider voltage divider rule from circuit 1, okay, it is the same here. Okay, I will just give you one example. Okay, please practice. See this example. If you find any difficulties, try to go to circuit 1, or try to see this example to practice more and more about the voltage divider rule. Voltage divider rule means that if I have a series circuit here, okay, and we have I need to find VC. I need to do this is the formula, which is ZC divided by multiplied by the E source. Okay, this is the E source. divided by plus ZC plus ZR. خلاص يا شباب. This is the formula. This is a formula of the voltage divider rule, and this is, as you can see here, if we start with VC, here should be ZC. If we start by VR, here with the source should be ZR. خلاص يا شباب. And the in the you can find that ZC is plus here plus ZR and ZC plus ZR, so they are the same. خلاص يا شباب. This is very easy example. We'll just take one example for the voltage divider rule, because we already know it in the circuit 1. خلاص يا شباب. Okay, we already know it in circuit 1, so no need to take more examples about it. Now, for the frequency response of series circuit, I will just give you the theory behind it. So the frequency response of the series circuit, thus far the analysis has been for a fixed frequency resulting in a fixed value for the reactance of the inductor or the capacitor. We now examine how the response of a series circuit changes as the frequency change. طيب يا شباب، لو تلاحظون هنا, as you can see here, we have the x-axis with the frequency and y-axis with the resistor. So this is the value of the resistor. Okay, let's say 10 ohm. Once we have more frequency, the value is the same of the resistor. The value is the same. It is 10 ohm. It will not change. Okay, but in case of inductor, shabab, in case of inductor, if the frequency increases, the value of the XL, hey shabab, increasing. That's why the factor here is 2 by FL, 2 by F. Okay shabab. So in case of inductor, once the frequency increases, the reactance of the inductance is increasing. Okay, XL is increasing. In case of capacitor, if we have more frequency, the value of XL is less. Okay شباب. Okay, is less. That's why we have 1 over 2 by FC. خلاص يا شباب. Okay. To conclude the information here, we will find that in case of resistor, more frequency, it is the same value. In case of inductor, more frequency, more XL. In case of capacitor, more frequency, less XL. Okay, and we know that the angle is 0 for the resistor, the angle is plus 90 for the XL, the angle is minus 90 for the XC here shabab. Okay, now this slide shabab, please this is very important. Shabab, for the midterm. Okay, this is a summary, okay, for the series circuit, AC circuit, and you will find some questions in the midterm coming from this slide. Okay, it might come with the true or false questions. It might come with the multiple choice questions. Okay, so try to understand each sentence here, and this is the summary for all the lecture. Okay, for this lecture. Now let us see sentence number 1. The total impedance will be frequency dependent. Okay, the total impedance will be frequency dependent, يعني تعتمد على الفريكونسي. خلاص يا شباب, which is obvious. okay شباب, لأن عندك كاباستر, the total impedance عندك كاباستر وعندك اندكتر, هي تتعامل مع الفريكونسي اصلا الاكس ال والاكس سي تتعامل مع الفريكونسي عشان كذا تعتمد على الفريكونسي. اوكي ذات امبيدنس. اوكي ناو number 2 the impedance of any one element can be greater than the total impedance of the network. It is obvious here that because لان اللي عندك الامبيدنس حق الاليمنت وحدها بتكون اعلى اكيد، لانه ما راح يكون عندك ما راح الزوايا تاثر وتقلل من قيمه التوتال امبيدنس. الزوايا تاثر فتقلل من التوتال امبيدنس. اوكي شباب، فطبيعي الشيء هذا. طيب نمبر 3 ناو نمبر 3 the inductive and the capacitive reactance are always in direct opposition on an impedance diagram. طبعا لان عارفين احنا الامبيدنس دياجرام حقنا كذا، صح ولا يا شباب؟ هنا الاكس ال لان بلس 90 وهنا الاكس سي ماينس 90، عشان كذا دائما هم opposite to each other. اوكي يا شباب، opposite to each other. now number 4 depending on the frequency applied، اعتمادا على الفريكونسي اللي موجودة على الدائرة، the same circuit can be either predominantly inductive or predominantly capacitive. أكيد لأنه إذا كانت قيمة الكاباستر أعلى، قيمة ال XC أعلى من قيمة ال XL، فأكيد أنها راح تكون predominantly مهيمنة قيمة الكاباستر. أوكي، فيسمونها دائرة مهيمنة كقيمة الكاباستر. أوكي، لكن إذا كانت قيمة ال XL أعلى من XC فتكون دائرة مهيمنة inductive. أوكي. Now number 5 at lower frequencies. Okay, lower frequencies the capacitive elements will usually have the most impact on the total impedance, while at high frequency the inductive elements will usually have the most impact. Okay. لأن يا شباب تخبرون لما قلنا لكم اللي هو الرسمة هذه فريكونسي، هذه الاكس سي، صح يا شباب؟ قلنا لكم رسمه كذا، لان at low frequency means هنا يا شباب، صح ولا لا يا شباب؟ هذا اللو فريكونسي هنا فيكون تأثير الاكس سي اعلى. ليش؟ لانه هنا عالي، لكن بالنسبة للاف مع الاكس ال، صح يا شباب كذا زيادته، فلما يكون عندي لو فريكونسي هنا يا شباب، صح، يكون عندي تأثير الاكسل قليل بعكس الكاباستر. خلاص، هذه منطقة الكاباستر وهذه منطقة الاكسل. واضح يا شباب؟ طيب سوري. Now the magnitude number 6 the magnitude of the voltage across any one element can be greater than the applied voltage. The magnitude of the voltage across any one element can be greater than the applied voltage. أكيد طبعا، لأن زي ما قلنا الابلايد فولتج على الدائرة بإمكانها أنها تقل، لأن هناك في زوايا، فعشان كده تأثر. فممكن الفاليو حق اي element موجود عندك اللي هو resistor capacitor inductor ممكن يكون الفولتج عليها اعلى من الفولتج applied على الدائره كامله، لان تاثير الزوايا ياثر على الفولتج supplied. اوكي. The magnitude now the magnitude number 7 the magnitude of the voltage across an element compared to the other elements of the circuit is directly related to the magnitude of its impedance. That is, the larger the impedance of an element is the larger of the magnitude of the voltage across the element. Of course, this is from circuit 1 from Ohm's law. We know that the larger of the impedance is meaning that the larger of the magnitude of the voltage across the element. Okay. Now for number 8, the voltages across a coil. The voltages across a coil or capacitor means inductor. Coil means inductor. Capacitor, we know, are always in direct opposition on a phasor diagram. Of course, they are opposite to each other from the phasor diagram. Now, the current is always in phase with the voltage across the resistive element, lags the voltage across the inductive element by 90 degree, and leads the voltage across the capacitive elements by 90 degree, which is we already know. Now for number 10, the larger the resistive element of a series compared to the net reactive impedance, the closer is the power factor to unity. المقصد هنا يا شباب لما يكون عندك عندك R وعندك مجموع ال XL وال XC، صح يا شباب؟ عندك هنا وهذه، فكل ما كانت قيمة الريال باور، هذا في حالة الباور إذا كان عندي باور، أوكي؟ لأن هذا يقصد الباور فاكتور، صح ولا لا يا شباب؟ الباور فاكتور تو يونيتي، قلنا لكم الباور فاكتور لازم يكون 1. طبعا مستحيل يوصل ل 1 لأنه في لوسز في السيستم، فإذا كانت قيمة الريزستور أعلى، لأن عندنا ما أدري خذيتوها يا شباب، عندنا شيء اسمه ريال باور ورياكتيف باور. هذا كل ما كان أقوى أو أكبر من هذا من الرياكتيف باور، فمعناته أن عندك الأمور تمام وعندك الباور فاكتور يونيتي تمام. لكن تأثير الإكسل والإكسي قوي في الدائرة، فعشان تخبرون شباب ما قلنا لكم الإكسل كذا في الدائرة والإكسي كذا، كل ما ما نفترض يا شباب تابع معي هنا، أوكي معلش. هذه إكس، هذا XL، شوفوا تلاحظون الفاليو حقه أعلى من الإكسي، صح يا شباب؟ الفاليو أعلى، فعشان أوصل الباور يونيتي عشان يكون عندي السيستم أموره تمام، فلازم أزود قيمة الكاباستر، قيمة الإكسي، صح ولا لا؟ عشان يكون عندي 0. فإذا كان عندي 0 وعندي قيمة الريزستور، إذا كان الإكسل minus XC is equal to 0 وعندي R، فمعناته عندي الباور فاكتور is 1. هذه أفضل حالة يا شباب، هذه أفضل حالة للسيستم عندك. أفضل حالة إنه يكون عندك الإكسل ناقص الإكسي equal to 0. إذا وصلت للحالة هذه، طبعا صعب إنك توصل لها، أوكي؟ فإذا وصلت لها فمعناته إن عندك السيستم أموره تمام وما في عندك خسائر كثيرة، بس ما عندك إلا خسائر الريال باور، ما عندك خسائر ريال باور ورياكتيف باور يا شباب، أوكي؟ لأن هذه كلها تعتبر خسائر. الريال باور اللي تستهلكه معقول ومعروف تمام، بس الرياكتيف باور مشكلته انه يأثر على السيستم، فعشان كذا لازم تخلي قيمة الXL تساوي الXC عشان تتخلص من المشكلة هذه من الرياكتيف باور. ان شاء الله اذا قدرنا ناخذ عنها تفاصيل اكثر ان شاء الله في المستقبل. شباب ارجوكم انتبهوا للسلايد هذا كثير، لأنه ممكن راح يجيك صح وخطأ، ممكن يجيك multiple choice، be careful يا شباب. خلاص يا شباب، this is very important, be careful and thank you so much for attending this lecture. I hope you understand well, and please try to go through it again before the coming quiz or exams. Be careful, try to study more and practice more and more about the calculations. Try to do some conversion between rectangular form to polar form, and stick with the slides. Inshallah you will be fine, okay? Thank you so much and stay safe.